Hello students. So today we'll be completing this particular module. Urban infrastructure assessment will be the last lecture in this module. What we'll be discussing today? First, obviously, we'll go for an overview on this urban infrastructure and assessment, and then the sectoral assessment we'll be discussing for the transport and linear infrastructure, water and drainage infrastructure, energy and power, and we'll be discussing frameworks, performance based planning frameworks, and climate smart cities assessment framework, which we have discussed in this particular week as well. Then we'll be concluding with the challenges and way forward. So let us go for the urban infrastructure. Infrastructure is the set of facilities and systems that serve a country or a city or any other area and encompasses the services and facilities necessary for its economy, households, and firms to function. There is hard infrastructure group and there is soft infrastructure group. What is hard infrastructure? That is the physical networks necessary for the functioning of a modern industrial society. And the soft infrastructure entails the institutions that maintain the economic, health, social, environmental, and cultural standards of a country or a city, whatever set you take. Urban infrastructure systems within the urban areas is transportation like roads, highways, railways, metro, parking, water and drainage, stormwater drainage, sewerage, piped water system, canals, energy utilities, and built environments like buildings, waste management. That is the hard infrastructure. So you have both hard and soft infrastructure under the urban infrastructure systems. In the Anthropocene, the distinction between the natural and the built environment has dissolved, especially in the cities. The old view about the infrastructure is that infrastructure is inert, it provides services like transport, water, like that, and sits on the land. But the new paradigm is different. Infrastructure is an active ecological agent. Infrastructure is not separate from ecosystems, but it actively shapes them. It modifies thermal regime, it alters the hydrological flows, it acts as a barrier to genetic flow, fragmentation. Urban infrastructure in today's time, the new paradigm is grey infrastructure, transport, water supply, sewage, drainage, energy, solid waste, etc. Green blue infrastructure, urban forest, wetlands, ponds, green roofs, floodplains, tanks, etc. Social and institutional infrastructure, which is again that hard and soft both, health, emergency services, governance capacity, etc. Negative impacts of urban infrastructure is habitat loss, fragmentation, hydrological modification, pollution, whereas the positive potential is there, like we can create green corridors, water retention, we can make it happen, biodiversity enhancement. Assessment challenges are existing for urban infrastructure, quantifying ecosystem services lost versus potentially restored. This is one very strong challenge in urban infrastructure assessment. Now, if we try to understand the theoretical perspective of this infrastructure assessment, let us understand the infrastructure ecology first. The transition to a green blue paradigm requires an integrated assessment. We must evaluate infrastructure not just on its engineering performance, like traffic volume, but also on its ecosystem service performance, like landscape permeability, heat mitigation, etc. Urban infrastructure, we look at it as service delivery systems, risk amplifiers, or buffers like heat, floods, and air pollution, enablers or constants for nature based solution. This shifting paradigms is from the asset condition to system performance, that means from gray only to hybrid, is a very, very strong shift into the urban urban infrastructure ecology understanding as well. Analyzing urban infrastructure not as isolated civil works but as a complex adaptive system analogous to biological ecosystem is the major tenet of the infrastructure ecology. Key interaction is gray-green interface. Scaling laws. Decentralized networks often show higher resilience than centralized one. Urban system exhibit scaling properties. Gibbs law similar to biological organism. Gibbs law is closely related to broader urban scaling research which examines how various urban indicators like GDP, innovation, rates or infrastructure requirements scale with the population size. The statistical underpinnings suggest a deep connection between the two phenomena. Valuing nature based solutions in planning, cost benefit analysis of NBS. We have discussed this particular premise earlier as well, but it is very pertinent to bring it back. To justify NBS in a performance based plan, we must value them. Grey infrastructure is easy in terms of cost, green infra benefits are diffused. So, we discussed several different ecosystem service estimations, and the last one, which we discussed in detail, is the total economic value. Direct use, like timber water, indirect use, like flood controls, carbon sequestration, use social cost of carbon, etc., and non-use existence value that also we discussed biodiversity. In Bangalore, studies showed that lake rejuvenation had a higher benefit cost ratio than building new grey STPs when ecosystem services were valued. That is exactly the reason that why we need to really assess. The economic imperative, why integrate ecology, the resilience dividend. CDRI Global Infra Resilience Report 2023 finding talks about the economic losses from service disruptions, which is 7.4 times higher than the direct damage to infrastructure assets. What is the implication of this finding? A road washing away costs, let's say, X to the repair of it, but the stop trade will cost you 7.4x. 75% of the infrastructure needed by 2050 is yet to build. We can avoid the lock in of fragile gray systems intelligently. Now, I will be discussing through a tabular form evolution of infrastructure assessment metrics. The dimensions are transport, drainage, built environment, and disaster resilience, and the traditional way of looking at them, like vehicle capacity, pavement roughness index, and we will also check the performance based ecological or integrated index, like landscape permeability index, wildlife mortality rate, roadkill per kilometer, carbon intensity of travel. For drainage, also similarly, hydraulic capacity, flow velocity. Whereas now we are trying to go for the integrated one and we are discussing infiltration rate, pollutant retention efficiency, groundwater recharge volume. In the environment, other than FAR and occupancy rates, we are discussing now urban vulnerability index, thermal comfort, habitat quality score. In the disaster resilience, repair cost estimates is the old way of looking at things. Now we are looking at resilience dividend, avoided loss. So that's the way this infrastructure assessment is also evolving. Transport and linear infrastructure. Linear infrastructure like roads, railways, power lines represents the most significant driver of habitat fragmentation. You can see the title of this slide also, linear intrusion problem. The barrier effect, roads and railways act as a semi-permeable membranes dissecting the habitats. Populations isolated by highways lose genetic diversity, becoming less viable. Age effects, disturbances like noise, light, invasive species extends hundreds of meters beyond the road edge. Assessing this impact requires landscape connectivity metrics, which measure the degree to which a landscape facilitates or impedes movement among resource patches. Core metrics of assessment. So you could understand the traditional assessment methods will not work anymore. We need to bring other tools also, complementary one, like core metrics for assessment. The structural connectivity measures the physical arrangement of habitat patches, Euclidean distance, nearest neighbor distance, like that. This is a static measure. Functional connectivity, that's a more integrated one, measures the behavioral response to organisms to landscape. It accounts for the fact that a tiger may cross a 50-meter gap that a frog cannot. Very true. Integral Index of Connectivity IIC, the graph theory based metric that evaluates the importance of each habitat patch and corridor in maintaining the overall network. There is probability of connectivity as well, similar to IIC but based on probabilistic dispersal kernels, where it may go. Next methodology which we'll be discussing, that is the circuit theory, and you can see here this image where this particular color is showing the very high and this color, bluish color, is the low color. You treat the landscape as an electrical circuit. Forest, the conductors, low resistance, and forest, the conductors, they are having low resistance, whereas the urban or the roads, they are the resistors, very high resistance. Tool is circuitscapes, and the map showing current density. High density indicates a pinch point or critical corridor where animals are forced to move, identifying exact location for wildlife crossings, and it helps a lot when you design the corridors. Mitigation design, bridging the gap. Assessment must lead to a design intervention. The goal is to restore the permeability. So, wildlife overpasses, these are the gold standard, typically 40 to 50-meter wide. They are landscaped with native vegetation to mimic the surrounding habitat. They allow for the passage of all from invertebrates to megafauna. But you can also make different routes for the small underpass and for the bigger fauna, megafaunas. They can also cross from the top, and in between you are having your car vehicular access. Underpasses, large mammal underpasses will require more than 10-meter width and the 4-meter height, essential for elephants and giraffes. Box culverts, useful for small mammals if dry ledges are provided to allow passage during the high water flow. Canopy bridges, you can have rope ladders or steel cables strung between trees across the road, critical for arboreal species like hullock gibbon or giant squirrels that cannot move on the ground. You can go for fencing. Mitigation is ineffective without funneling. Fencing guides animals to the crossing structures. However, if it is not done properly, then the fencing may trap the animals on the road. So it has to be designed, implemented, and maintained. I can give you a good example from the Pench Tiger Reserve. This is NH44, which bisects the critical corridor between Pench Tiger Reserve and the Satpura. The pre-construction assessment predicted severe fragmentation of the tiger population. Development versus the conservation is the conflict. Transport efficiency and the tiger connectivity. These are the two indicators. So, the infrastructure as ecological integration, we can find that construction of 9 dedicated wildlife crossings. You can see these wildlife crossings in different locations. Animal underpass, minor bridges. You just see here minor bridges and animal underpass. and 750-meter underpasses among the largest in the world, 300-meter underpasses designed for light and visibility. Reduce the tunnel effect to encourage prey species like chital, gaur to enter. Did it work? 2019 to 2020, for 1 year it was monitored. 18 to 21 mammal species recorded using this structure. 89 crossings by 11 unique tigers in 10 months. The prey trap fear, critics feared predators would ambush prey in the tunnels, but analysis of time gap showed no statistical evidence for trapping. Predator prey dynamics mimic the open forest. Large spans, more than 50 meter, are essential for herd animals because huge sizes as well as numbers you have to really consider. Now we come for the water and drainage, the next infra. Urban hydrology paradox in India, the grey approach, rapid conveyance, flush water out first. Urban flooding and groundwater depletion, things are happening together. The blue green approach, retain and infiltrate. The result is you mitigate the flood as well as your aquifer is recharged. Infiltration rate and runoff retention, they are the assessment metric. Urbanization, 10 to 10% runoff and 50% infiltration. Urban, 55% runoff and 15% infiltration. Goal is restore the 50% infiltration target. We discussed this integrated urban water management. I hope you remember, isn't it? A holistic framework. We talked about it in details, which manages the entire urban water cycle, supply, sanitation, and stormwater as an integrated system. And this views stormwater not as a hazard, not as a burden, but as a resource. IUWM assessment criteria are enabling environment, very important, policies and legislation, institutional arrangements. Cross departmental coordination is the drainage department in contact with the water supply board. That is always happening. This not to have a good discussion among the different stakeholding groups. Management instruments, data, maps, and models. Sustainable urban drainage systems, another good model which we discussed, that is, or you can say sponge city concept, which utilizes the nature-based solutions to manage hydrological flows. And when you go for the performance assessment, interventions you can assess, bioswale, permeable pavements, rain gardens. Assessment tools are there, SWMM, coupled with green infra modules. Key indicators is peak flow reduction. And case examples, I can again cite Bengaluru. The modeling shows that decentralized recharge wells can significantly reduce local flooding if connected to Raja Kaluve, that is traditional stormwater network. The another case example I will like to bring here, that is Jamuna Biodiversity Park in Delhi. There's the floodplain as the infrastructure, and many countries actually have gone for it. Again and again I bring the example of Kyoto city. They have also used the floodplain as the infra. Dead river encroachment, loss of flood buffer, that's the challenge. Intervention, restoring 457 acres of floodplain, dredging wetlands to reconnect with the river during monsoons, planting native riparian flora. Performance, flood service acts as a detention basin for millions of liters of floodwaters, and biodiversity, return of red-crested pockard. Next sector is energy and power, and in this sector we will first discuss the vulnerability to disasters. Power sectors account for a significant portion of infrastructure losses in cyclones. Cyclone Fani, Orissa, anything happens, any strong wind, we first see the casualties, the power lines. Wind damage to transmission towers, flooding of substation, that is really havoc during these different cyclones, strong cyclones. Tree falling on power lines is a major cause of outage. We want trees for cooling, but they threaten the power lines. That's the conflict. So what we find that in Odisha power sector, the CDRI project on the resilience, the government of Odisha has gone for a project where they assessed probabilistic risk assessment of transmission and distribution assets in coastal zones, 60-kilometer buffer from the coast. Findings: concrete poles are brittle, still lattice towers have specific wind threshold. Till certain winds speed, it can really take care. Vegetation management rather than clear felling. Identifying wind resistant native tree species for power corridors. And hard intervention, the suggested one is shift to spun concrete poles and underground cabling in high risk zones. Very, very realistic, wise intervention suggested. Performance based planning frameworks for this infrastructure assessment. PBPP, it defines desired outcomes such as specific flood risk reduction targets, biodiversity connectivity indices, or thermal comfort levels. You have any target and allows the planner to select the optimal mix of gray and green interventions to achieve them. So the authority provides the target and then the planners will explore the options. Tools for the modern planner. Landscape connectivity metrics is very helpful for transport and linear intrusions like circuitscapes, which we discussed. Ecosystem service valuation like blue green infrastructure, invest model, TEV, etc. Vulnerability indices for disaster risk exposure like UBI, CSCF. Resilience scorecards, CDRI, and MOHUA frameworks, which we discussed. This PBPP can be effectively integrated with the urban infra ecosystem, shifting planning from prescriptive zoning to outcome based performance. Eco performance metrics, like in Italy, we have seen the cities have integrated this PBPP into master plans by requiring new developments to meet specific ecological performance score, rainfall infiltration effectiveness, RIE index for soil permeability to gain the building permits. So you bring it into the policy as well. NBSS infrastructure assets in a PBPP framework, NBSS like green roofs or urban wetlands are treated as a functional infrastructure. Their performance in reducing urban heat or managing stormwater is measured against regional environmental targets. Multi objective programming, PBPP allows agencies to link transport investment with other urban goals. Example like transportation project might be programmed only if it meets performance targets for air quality or flood resilience through integrated green corridors. Then only that particular project will get the approval. So this is multi-objective programming. So that's the way performance-based planning and programming is very different from our traditional way of planning. So this shifts planning from prescriptive standards to measurable infrastructure performance outcomes under real constraints of soil, climate, assets, and governance. Planning decisions are guided by measurable system performance rather than prescriptive standards or uniform design templates. Key attributes are explicit performance metrics, context responsive thresholds, asset plus system performance, monitoring and feedback, adaptive programming, etc. If you take this performance metrics, you can see that even within the performance metrics, you can look at the runoff volume reduction, flood depth duration, infrastructure service reliability, recovery time, environmental load reduction, etc. So for each one of them, you can go for certain sub performance metrics identification. I will discuss two cases with you. First one is Warangal from Telangana. Let me give you some background to this particular case. Urban tank network and drainage modernization. In response to this haphazard urbanization, the authorities and state agencies, they initiated a series of interventions aimed at understanding and improving the performance of the city's drainage and water storage systems. What is the traditional water storage systems they have? They have the traditional tanks. These efforts focused on mapping tank cascades, identifying encroachments, assessing drainage bottlenecks, and evaluating the interaction between roads, culverts, and natural flow paths. Rather than treating tanks solely as heritage or recreational assets, which happens in most of the cities, the project gradually repositioned these tanks as critical components of urban infrastructure. And their cascade means who is on the higher level, in the next level, who can take that water, additional runoff. Everything was mapped. This initiative in the Warangal represent a shift toward recognizing traditional water systems within contemporary urban planning with emphasis on restoring connectivity, improving flood moderation, and integrating water bodies into broader infrastructure management strategies. So, the PBPP framing hierarchical performance over asset provision. Instead of asking how many drains or how wide the road should be, the assessment asked, does the system safely convey, store, and release stormwater? Are tanks functioning as flood buffering infrastructure? So the questions were different. The insights gained out of this project is decisions were guided by whether flood performance improved, infiltration was selectively applied, not mandated or prescribed. For shallow or compacted soils, performance shifted to storage because there you cannot expect lot of good performance. Infrastructure redesign was justified by measured failures, not norms. Gray upgrades were justified only if they improved the system performance. So that's the way Warangal is a very good case for this PBPP framing. The next case, the Philadelphia Green City and Clean Waters from USA. And this program is also another eye opener which address long standing water pollution problems caused by the combined sewer overflows CSO. In 2011, the program came and used the green infrastructure. The program proposed to reduce runoff entering the sewer system by capturing, infiltrating, or evapotranspiring the rainwater close to where it falls so that it doesn't come into the system. Over a 25-year implementation horizon, the initiative introduced a wide range of interventions, including rain gardens, permeable pavements, green roofs, and tree based systems, applied across streets, public spaces, and private properties. The program required extensive coordination. You can understand that between the water utility, planning agencies, and communities, as well as new regulatory and financing mechanism. This particular project is recognized for repositioning stormwater management as an urban system challenge rather than a purely underground engineering problem. Integrating land use, infrastructure, and environmental management objectives. So, it is again another good case of PBPP. So, the framing was runoff reduction performance replacing sewer expansion. So, what is the performance was asked from the project? How much runoff volume must be removed from the combined sewer system? Not that how many rain gardens or how much green cover. So the performance target was fixed that this is the amount of runoff needs to be removed from the system. It cannot take anymore. Insight from this project is success judged by measured performance, not visual greenness. Green infrastructure treated as regulated infrastructure. Planning, design, operation, and maintenance aligned to performance targets. Performance monitored continuously. Designs changed when infiltration underperformed. So it's a flexi system as well. Climate Smart Cities Assessment Framework, CSCAF, we have discussed it previously also, and we will now come back with an additional discussion that how this particular framework works. There are 5 assessment themes: urban planning, green cover and biodiversity, indicators like proportion of green cover, like the target is more than 12% URDPFI norm. Indicators City Biodiversity Index, the Singapore Index implementation. Second theme is energy and green building, where the indicator chosen is percentage of renewable energy in the mix. Third thematic area is mobility and air quality indicator, coverage of non-motorized transport network. Fourth one is water management, where the indicator is non-revenue water reduction, indicator is flood risk assessment coverage. And the fifth, the final theme is the waste management, indicator is landfill diversion rates. For assessment, you can understand, you can develop a policy, and you can also identify the indicators through which you will be assessing. You can also go for the assessment process, but then also there are a lot of strong challenges in this assessment. Why this is hard? Because data scarcity, first thing first. Lack of high resolution LiDAR or hydrological data in Indian cities, that is creating lot of problem. Siloed governance, roads department doesn't talk to the forest department or the sanitation department. Complexity, ecological systems are non-linear, engineering systems are linear. Modeling the interaction is computationally heavy if you go for ecological system. Maintenance, the grey infra fails visibly, green infra fails silently. A clogged bioswale looks like a patch of grass. It takes time to understand that it is not functioning. Emerging trends in assessment, we can find that linking assessment to policy like environmental impact assessment, mandatory for large projects, but often lacks post project monitoring. Strategic environmental assessment assesses the policy itself, like assessing a master plan, not just a building. NDMA guidelines now emphasize building back better. So, assessment becomes a very important that whether it's a better one or not. The future of measurement, digital twins creating a virtual replica of the city to test what if scenarios for flooding or heat or any other challenge. IoT and sensors, real time monitoring of soil moisture in biosoils or water levels in drains. Drone or UAV mapping for rapid post disaster assessment of infra and vegetation damage. So, there are also new trends in the assessment. You are using new tools, new techniques. Future outlook, active agency infrastructure is not inert. It drives ecological change, it modifies thermal, hydrological, and biological regimes, which is accepted now. Integration is resilience. The separation of grey and green leads to fragility. Hybrid systems are robust against the volatility of the Anthropocene. Assessment drives design. Use tools like InVest or CircuitScape to quantify the impacts, because now these tools are available to you. Economic argument, the resilience dividend justifies the investment in NBS. So, today we have discussed a lot on this infrastructure assessment, overview, sectoral assessment like transport and linear infrastructure, water and drainage, energy and power. And then we discussed that PBPP, performance based planning frameworks, and climate smart cities assessment framework also we discussed, and challenges and way forward. So, with this, you can see a long list of references waiting for you. Thank you. We'll be meeting next week.